Good day, everybody. This is Keith Peterson, the product manager for the Trimble eCognition software suite. And today we're happy to present this time we are going to be doing an eCognition Power Hour. The Power Hours are designed to look at a specific topic in some detail. And specifically, we're going to be diving right into using the software live here, so you can relax and watch how we are working within the eCognition developer software. Today's topic is object-based image analysis and point cloud analytics within developer, and just have a few slides introducing this concept, a relatively new concept within developer, that we'll go through, and then we'll jump right into several examples in the software. That being said, welcome to the webinar, and you can ask a question at any time. You are on mute mode or on listen only mode, but you can use the question dialog field here in the GoToWebinar and ask your questions at any time during the webinar, and we'll have a few breaks here and there to answer the questions. If for whatever reason you early or you came into the webinar late, maybe don't worry, this session is being recorded and it will be available in the Trimble Geospatial webinar archive after the webinar has been completed. So that being said, let's get right into our topic here today, point cloud analytics within eCognition. Just a brief overview of what we'll be looking at. First, introduce some of these new point cloud tools and features that are available in version 9.3.1. That is the latest version of eCognition Developer. We're then going to look at how we can convert image objects to point clouds directly within Developer. Also, how we can write values from, say, various feature values directly into our point cloud. And then finally, we're going to be looking at point cloud colorization and several methods, basic and advanced methods, if you will, for doing point cloud colorization within Developer. So for those of you that may not be fully aware, we released eCognition 9.3.1, and it has added not just some nice patches to the software as a maintenance release, but we've also extended certain functionality within the software, particularly for point cloud, the use of point clouds, and either just the new features that are valid for working with point cloud. So first of all, we've extended support 19 different point cloud fields, including the near infrared. So prior to that, we were just supporting the RGB fields. As well as scan angle and various other valuable fields that can be used in the eCognition workflow. In addition, we've intensified object-based point cloud analytics by allowing us to create point clouds, like I said, directly from image objects. This has some really cool potential, as I'll show in the demonstrations here, and to compute statistical values from the point cloud for additional features and variables within Developer. So that is what we will be looking at in the next hour here. So now right to the demonstration. How does this all work within eCognition? And again, I iterate within eCognition Developer. We'll get into our developer. We see here, we have an image. Not only do we have an image, but if I open up our image layer, of the different layers that we have available. Here's my menu has disappeared here. Apologize. Here we are. So I see I'm not only dealing with an RGB, I also have a near infrared. I also have a DSM and DTM layers available to me. We can scroll through this data very easily using the image layer mixing dialog. Of particular interest here is the DSM and the DTM data that we have. Very good. It's all loaded in Developer. We're going to work on a rule set, creating a rule set. Now here we want to simply convert these values. We want to create a point cloud from image objects. As you saw here, there is no point cloud data available. If there were, the point cloud layer mixing dialog would be active in developer, and there is no point cloud. We're going to create what we call a temporary point cloud directly within eCognition developer. So we use the process tree for creating any of these workflows, or as we call them in eCognition, rule sets. I'm going to, first of all, create image objects. Do this very simply in this example. Click append new. I'm going to use a chessboard segmentation, create just simple square objects here. Use a chessboard 6 size in this just for this example. Execute this. You now see I have image objects available within my project. If I zoom in, I can see these image objects. I can click on one and I can get information about that image object. So the next step is, once I have image objects, whether they come from a chessboard segmentation, whether they come from a multi-resolution segmentation, whether they come from a threshold segmentation, there are various segmentation algorithms available within eCognition. Regardless of how I create these image objects, I need image objects, and then I can convert these directly into a point cloud. There is a newer algorithm available within developer, and right click within my process tree, say append new. And what we have here is an algorithm. If you can go into this drop-down menu, you can scroll through and look for the algorithm. It is called a create temporary point cloud. I know the name, so I'm just actually going to start typing it in this dialog. And I see the create temporary point cloud layer available here. So there are several parameters that we need to consider within this create temporary point cloud algorithm. First of all, since I'm going to be creating my temporary point cloud based on image objects, I need to change my domain, which by default is set to the pixel domain, first of all, to image object level. So I'm going to say we're going to be creating objects. This is what launches this dialog. If I had, for example, now in this project, an existing classification or varying image object levels, I could use these. I could use my domain like I do in any traditional object-based image analysis algorithm within eCognition to set filters and specifications. Maybe I only want to convert vegetated image objects to a point cloud. So you could set that with the class filter.
Sorry to interrupt you. We have some audio issues. Maybe we take a minute to fix that.
Sure, we can. Is it audio on my side or?
Yes, it is audio on your side. I think it's better to dial in via phone.
Okay, I will dial in via phone and be right back. So just a moment.
Okay, everybody, I should be back into this webinar with a better audio connection now via telephone. I apologize for the crumbling internet connection out of Munich today. If you have any issues hearing me now, please just raise your hand in the question dialog box. I'm going to just take a few steps back now for those of you that could not hear me due to audio. And we'll get back to the beginning of this scenario. So again, I have an image loaded here with corresponding DSM and DTM as a raster imagery in this project. But what I would like to do is I don't have any point cloud available to me. As you can see here in this point cloud layer mixing dialog is grayed out. It's not available at the moment. So I want to create image objects. I will then convert these image objects into a point cloud. So I'm going to use a straightforward chessboard segmentation algorithm to do this. I had added this previously. I'm going to just create square objects here. Zoom in to take a look at these. And we see that they are nice small square objects in this project. The second step is using a relatively new algorithm. This algorithm is called the create temporary point cloud. So you can either search through the drop-down menu, or simply start typing the name of the algorithm if you know these, and you see create temporary point cloud. This algorithm provides a number of options for creating different point clouds within eCognition. And since we are going to want to create our point cloud from image objects, the first thing I need to do is set up this domain field here. So as you see, by default, it's going to be on the pixel level domain. Here, I want to set this to my image object level. This gives me additional options. If I had a more advanced classification, for example, available here, I could select a specific class to use for converting image objects to point cloud. I could specify maybe I'm only interested in forested objects and use my class filter, for example, to apply this. In this case, I have no classification available, so I will leave the default. I'm working in the new level, which is our image object level. I do not have any classes, so I'll leave this as none. The second parameter now that we want to look at is here the method. As you can see, there are several methods available. We can create this temporary point cloud very quickly. We can create it with modified fields where we can adjust the various point cloud fields on the fly here within eCognition, or as we can see, a third option, create point cloud from the object domain, in this case, meaning I'm going to use my image objects to create these points. We can give this output layer a name. We could call it my point cloud. Oops. And we could also define the map to use. In this case, we'll use the map from our domain, and this we see is set to from parent. And it will look to our parent algorithm. Since we have none, it's going to default and use the main map, which is the only map we have available to us. So just setting and leaving the default here. We now get into the more interesting fields that we want to populate within this point cloud. Obviously, within our point cloud, we would like an X, Y, and Z coordinate, ideally, if we're looking to generate any type of a 3D point cloud. So we can call up any of these fields from, say, an original value if we're deriving it, creating a point cloud based on another point cloud. But we can also fill these field values based on a feature that's within eCognition. So for the X coordinate field, most likely we would want to use a position feature. So we see under object features, the option here for position, and we have coordinates. And there are various coordinates here that correspond to the image object or objects that we've created. So for example, I see here we have a feature called X center, and I can use this as a coordinate. By default, when we start eCognition, many of these features are going to be set in pixels because we don't know what type of units you are going to want to be working with from the outset of a project. So I can see here that currently my X center feature is in the pixel units. Very important here to then right click on this and say edit unit. And I can then select coordinates from the drop down, and now I can see this is X center in coordinates. And I can just say OK. That is going to be the feature that's used for the X coordinate. You can do the same for the Y. Again, just hit feature, position, coordinate. Make sure I switch this unit and say OK. Finally, we have the option here for Z coordinate. Where are we going to derive this? Obviously, from say the initial image. If it's just an RGB, there's not necessarily the Z coordinate here. So we can also take this from a feature. And in this case, we have these additional layers available within our project. Remember the DSM and the DTM that were shown at the beginning. And we could take, for example, the mean value of our DSM, our digital surface model. Click OK. And we will use that value to populate the Z coordinate. You can see these are the other fields that are supported within eCognition at the moment, and we can populate any of these based on any type of feature within eCognition. We can also keep the original values. So in this case, by keeping the original values, we will just leave these fields empty. So this is what we're going to do. We're going to create a point cloud called My Point Cloud from these layers. I'm going to say OK. And finally, I'm going to execute this algorithm. And it should run relatively quickly for this this particular image and this data set that we have available to us. So our point cloud has now been created. Because it's a point cloud, we don't automatically display this in the viewer. As you can see, nothing has changed here. I still see my image objects. I still see my imagery. So I'm going to just click here to turn off the image object outlines. And I can come into now to my image layer mixing dialog. And this may be new for some of our existing users out here. It's now possible to turn off all of our layers here. You can see we also have a layer here called My Point Cloud. So there is there's always going to be a raster layer that corresponds to our point cloud created by default here within eCognition. I'm not interested in the raster layer though. So I'm going to turn off all my raster layers. And now I see that this point cloud layer mixing dialog is no longer grayed out. That means it's active. I have a point cloud available to me. And I can see here point cloud, My Point Cloud. And we can turn this on via show. And by default, we'll always be displaying the height. So I can control the size of my points here with the display. I can create extra large points here and click OK. And now if I zoom in to this this layer, I can see that I have created a point for each one of my image objects available to me within eCognition. So here we go. I'm now in. I can select each one of these points. And another nice piece of working with point clouds now within eCognition is a point will also have its features. As we see, we have these 19 available fields available. So I can display these within the image object information, so you have point cloud related features. So I have these point fields. I'm just going to double click here and add all of those fields to my selected feature list here. Click OK. And now when I click on a point, expand this window out a bit, I can see the feature values for that particular point. So remember, we didn't fill any of these fields here, so they're going to be 0 or undefined. But I do have values now that came from my X center, Y center features, as well as, of course, the Z data that's coming from that digital surface model that we loaded in. We can also view these points in a 3D or a 2.5D, if you will, within eCognition. So once I have turned on my point cloud, this 3D subset selection tool will become available. And I can simply come in and draw a box around the area that I would like to examine in 3D. And we can see now using the mouse, so this is using the right-hand mouse button, I can pan and scroll through this scene, zoom in and out, and navigate through the point cloud always. So you'll notice that in this left-hand window, if you get lost when navigating, this will also show you with the arrow from what direction you're viewing your point cloud now and within eCognition. So you have a better orientation. You can also then come up and close out of this window when you're done. So that was a very simple demonstration of this new algorithm to simply create a point cloud based right from our image objects and the values in our existing layers. Another example that we can show here is, what if I want to calculate a new feature within eCognition, and I would like to write this feature into one of the point cloud fields. An excellent example is, because here I have a DSM and a DTM, I can then create an NDSM, and I can create then add these normalized elevation values to the point cloud. And that's what we'll do here. So I'm just going to add this algorithm in above our current create temporary point cloud algorithm. Say append new, and we can use our layer arithmetics algorithm to add this. Apologize for some of the display issues we're having today. Internet is a bit weak. And we could enter our algorithm right here very easily. DSM minus DTM creates NDSM, and we will just create an additional layer within eCognition. Alternatively, because I'm working with image objects, I can also simply come into my feature view. I can create a customized feature and use this create new arithmetic features dialog. And I'll just right here, just to make a difference here, NDSM. And I can use this tool to do the same exact thing. So here I'm just going to select the DSM feature minus my DTM, and I'll say OK. Now if I click on an image object, for example, I'll turn back on my image layer. And I can see now here's my customized feature. If I turn on my object outlines, I'll turn off the points so it's not as cluttered. And I zoom into an object. For this object, I'm now seeing that mean NDSM value that was available here in this feature.
Keith, we have one question from our viewers who are asking where the DSM comes from, because the image was including the DSM.
Right, so in this case, we had a DSM layer available to us. This DSM could have come from another, in this case, it came from another source. It could have been a photogrammetric source. Someone created a DSM product in a photogrammetric software such as Info, or it could have been derived from a point cloud previously. In this case, I'm showing the example. We have the DSM only available to us as a raster, but I'd like to also have a point cloud. So these rasterized elevation products are typically derived through some of those sources. Any other questions at the moment, Sebastian?
Not yet.
Okay,
maybe
excellent.
Some interesting questions later.
Yes, if you have those questions, just send them in, and ZC will get those answers. So we've created our NDSM feature here. And now I would like to actually use this feature that we've created within eCognition to populate the field, say this Z coordinate field, within my point cloud. So again, we can use the same algorithm, this create temporary point cloud algorithm. I'll just copy and paste this within the rule set and drag it down the bottom here. And I just have to edit this now to change the mean DSM to a new feature. And in this case, I'm going to look at that customized feature, the customized arithmetic feature that I created. And that's my NDSM. I will say OK. That is now available here. I can also change the name of this point cloud, and we'll just say my point cloud NDSM. And again, keeping it or deriving it from image objects, that all still stays the same. Then execute this algorithm. Ran through very quickly, and we can once again turn off our image layers and examine this point cloud. Also make sure we turn off our image object outlines. And now you'll see I have 2 point clouds available to me within this mixing dialog, so you can have multiple point clouds loaded into the same project or created within the same project. And now I have this point cloud that's been created based on the NDSM, and you can quickly see the difference is that our points that were at ground level are very close to or equal to 0, and the points of any elevated objects now reflect the height above ground for that object, and not the height above ground plus elevation. It's also a very useful tool within eCognition, being able to populate these point cloud fields as you like from any type of feature that you want, and then use it within the analysis or export this as a product. And this is the same. We can write NDVI values into this, considering the restrictions of LAS formatting, of course, when writing those values in, but any of these features are available. Of course, we have this available as a temporary point cloud within eCognition. The last step to do would be then to export this point cloud out of eCognition. So we can take a look at our export point cloud algorithm. And this allows us to select the point cloud that we would like to export. So I have several here. And if you had class filters available within the point cloud, again, you can set that class filter within this mode. And you have several options for exporting, and within the file format, we can export a LAS, and we have the LAS 1.4 support here, or you can even export an LAZ file, so that compressed LAS format here as well. And that would then be available to you outside eCognition as any LAS file would. Any questions at this point? If not, then be happy to move on to the next exercise. Sebastian, how's it look?
One question is if there is an option to add a color ramp to the point cloud map.
A color ramp, well, that's what we're looking at right here. There's a color ramp available for the elevation. When we visualize a point cloud, we have several options. We can look at the rendering mode here as a fixed color. We can use we look at the color ramp in terms of classification, if there's a classification there. The intensity, color-coded intensity, or RGB, if there's an RGB value associated with the point cloud, and that would then move us into the next exercise. But you cannot set a customized color ramp here.
One more question. Are there any restrictions of point cloud sizes or volumes?
No, the restrictions in terms of the software, we don't restrict due to 1 million points, for example. Whether you would see restrictions as more on your hardware from your side as what kind of volumes can your computer handle from a memory perspective and things of that nature. But eCognition does not make a restriction on the number of points. It's the same in terms of imagery. There's no limitation to the number of objects that you can have within eCognition. There's no limitation on the size of an image that you can load in eCognition from our software perspective. It's more related to what capabilities your specific hardware has. Okay. Excellent. So this was quick and painless, I hope, for most of you, a demonstration of how we can very easily create image objects within our project here using a chessboard segmentation, and then take those image objects and convert them to a point cloud. In this case, we chose something that's very similar to the pixel size here, so we could use the pixel resolution of our DSM and DTM. But again, as I said earlier, you can use image object that came out of a multi-resolution segmentation algorithm or something else. That's not an issue. And then any of those features that are available or that you create, such as NDSM, NDVI, any type of indice, you can also use to populate the fields of that point cloud. So in the second part of this power hour, we want to look at the topic of point cloud colorization or colorizer here. This is the rule set we've put together here. In this particular case, I have an image. This is an RGB image. I also have a point cloud available already. So if I turn this point cloud on, I see this is my layer 4. And we'll take a look at how this point cloud compares to our imagery, because this poses the interesting challenge for this particular exercise. So now I've turned on my point cloud. I've overlain it on my raster image. And I start to see a few discrepancies between the point cloud and in my image data. First of all, we're seeing this offset between the tree as it was captured in the point cloud compared to how it is captured in the image. So we have this offset, which will affect the colorization that we do. Since what we're going to do is we're going to derive the color for these RGB values for the point cloud from our image, and there are several methods or approaches that you can take to doing this. First of all, walk through a very simple, straightforward method on doing this, and we can see here in this basic, it's as simple as a single algorithm within eCognition. Sometimes it can be that easy. So let's take a look at this algorithm. Should seem familiar based on what we just saw in the previous exercise. I'm going to be creating a temporary point cloud here. If I want to alter a point cloud within eCognition, it will require creating this temporary temporary point cloud file. So this time we're going to be working on a pixel level domain, if we can see here. I am going to simply have to state what points do I want to use here. I'm deriving my points from layer 4. So when we import a point cloud into eCognition, it's handled like any other image layer or layer that we have. We assign it this default name. In this case, it was the 4th layer I added, so it's called layer 4. This contains my point data. If I scroll down, I'm just saying, well, what do I want to do here? I want to create a new temporary point cloud, and we're going to call this point cloud PC point cloud color A. And since I have my X, Y, Z, remember I changed those in the previous exercise because I was creating the point cloud directly from image objects. I had to define what these values are. Here, I'm going to keep the original values, so I'll keep these original X, Y, and Z coordinate values as they were from the point cloud layer that I've stated here, so layer 4. What I want to then define is down here. I'm looking at writing values in for the red, green, and blue. As I said, we support those 4 fields, red, green, blue, and near infrared. Because I only have the red, green, and blue available to me in this image, I will use these. And we have the options to do this, again, from a feature. And if I open up this feature dialog, we have within a point cloud related features, you also have the layer pixel value at point, and you can create this or these values as you see fit within eCognition. So I've created this simply for layers 1, 2, and 3 corresponding to my red, green, and blue within eCognition. So I've assigned those to layer 1 being my red layer. I would like to write that pixel value into the red here. I'm going to take layer 2, write it to green, and layer 3 to blue. So what this will do is simply take the pixel that corresponds to a point and write simply write that value into it, not considering any other things that we're looking at. So we can execute this algorithm, and we'll create this point cloud here within eCognition. And just zoom out. I'm still looking at the initial point cloud that I had in my viewer. If I now go to the point cloud layer mixing settings, I see I now have this point cloud called PC Color A. And we can choose to visualize this. Again, by default, the render mode will be in height. And I can now look at this in RGB. And it will render the point cloud based on those RGB values from the pixel. I'll say OK. And to prove this, I'm going to turn off my image that's currently on in the background. So now I see I am looking at the point cloud here, and we can see that they are points. I zoom in, again, see this a little better. So the points have been given the RGB value. This is also, of course, viewable in, say, a 3D environment. And this is where it gets rather interesting, is that we see, since we just did this without much intelligence attached to it, that we have a number of ground points here that have been assigned the color of our tree, because if you remember, there was that discrepancy in the overlap between the point cloud and the imagery. There's that slight offset, and those values are now, we have this road that has these green tree values to this. And this is something that's not maybe the ideal situation. And we can use various OBIA tools to then make this a smarter point cloud colorization. And this is where we get into this, the real topic, the beef of this webinar, is looking at the various object-based image analysis tools we have available to us to do point cloud analytics within eCognition. So we'll leave this, this point cloud that we can compare to later. I'm just going to turn it off. Let's see, okay. And I'm going to come back in here and turn on my imagery. So what are we going to do? What can we do within eCognition to make this point cloud colorization smarter? I'm calling this the advanced method. So the first thing I need to do is I'm going to create image objects. I'm going to run a segmentation here. So in this case, I'm going to be using our multi-resolution segmentation algorithm, very well suited for imagery remote sensing data. I will let this run and create the initial image objects here. As you can see in the algorithm, it's just running off the RGB information here, not considering any information from the existing point cloud. And this will be my initial step, of course. And from here, we will then go on to classify some elevated areas within eCognition. So this is ready. We now have our image objects here. I can see that these image objects correspond nicely to the trees as they appear in our imagery. The next step here that I'm going to take, and I will make this window a bit smaller, is now I'm just going to throw all my elevated objects and any elevated features within my image into just a sort of a bin layer for these. And to do this, I'm now going to integrate data that I have available to me from the point cloud. And one of these algorithms is the automatic point cloud classification. And here I'm defining what point cloud to use, in this case my layer 4. And I'm telling eCognition classify ground and then throw everything else into the rest of the points into an unclassified class within this point cloud. And this will do this based on the algorithms driving this algorithm. And finally, next step is then I want to rasterize an element of this point cloud. So in this case, I'm going to rasterize the point cloud based on the number of points. I'm also going to be applying a small kernel here to do some simplification of this raster layer. I'm going to apply this only to the unclassified points that are within my point cloud layer here. So I've defined my point cloud layer. I've defined the class filter to be unclassified. And I'm going to run this algorithm and create a layer called point count elevated. And then finally just going to add a layer arithmetics, run a simple multiplier to these values. Anything over, we're just multiplying by 1. And we'll take a look at the layer that we create here within our image layer mixing. So I see this elevated features layer. That's the one that I'm sort of storing these elevated features in this bin layer. That's what I've called it here. So we can jump right down to this layer. And we can see this corresponds very well with a buffer that's coming from our kernel. So we did some simplification here, and we have this that corresponds nicely to the trees and the buildings here. So we'll get back to our RGB view. I'm going to use this to create an initial classification of elevated features. So that's what we're doing here in the next algorithm. Is I'm using an assign class. And I'm simply going to say, if we have any object that overlaps with this this layer by 50% or more, it's going to be considered an elevated object. So if I turn on my classification view now, I see that these objects, they overlap by 50% or more, and they've been put into this elevated class. The next step is I'm using a multi-threshold segmentation algorithm, and I'm going to create just a temporary class. I'm calling it temp class 02 here. And anything that is, if we have a minimum object size set to 0, it's being also derived from this elevated features layer. And here we'll let this run, and we start to see now these objects that we're going to consider them conflicts. So we know that there's something appears elevated in our image, but not necessarily in our point cloud. So we want to identify these so we can handle them when we make our temporary point cloud. Finally, I'm going to just merge our unclassified area. That's essentially just the ground. And next, I'm going to apply a chessboard segmentation to this unclassified image object. I'm doing this because, as you'll see later, I'm going to then derive the values from neighboring objects here. So I need to establish some neighboring objects. I'm going to use these relational features within eCognition to determine the RGB values for certain points within our point cloud. So up until now, we've been working in our object, I'd say that traditional object domain within eCognition. We're using data from our imagery. We're using data from the point cloud within this project to create these classes. The next step now is to take these the data from these image objects and use it now to colorize our point cloud in a more intelligent manner. So the first thing I'm going to do is create a point cloud for non-elevated objects, or based on the color from these non-elevated objects. So here, my non-elevated objects are simply in this class of unclassified. So again, you can see I'm going to be using this image object level domain. Here, I have my class filter set to unclassified. My point cloud layer is defined here as a layer 4. So here I'm not going to be creating a new point cloud based on these image objects. I'm going to be modifying the fields of our point cloud based on these objects. So here I'm setting no class filter. I'm going to create a new temporary point cloud within eCognition called PC color B, non-elevated. So just to remind myself, the first one we created was point cloud color A. This is method B, and this is just for non-elevated image objects. And I'm keeping all these values the same, again, except for the RGB. This time I'm again using this pixel value at the point for these unclassified objects. So we'll let this run, and we can take a look at the image objects that we create here, or excuse me, at the point cloud that we're creating. Turn off our layer. And now when we go into point cloud, I see my PC color non-elevated B. And you can see we've just taken those unclassified image objects and colored the points that correspond to them based on the RGB values. So looking at those, everything looks nice at the moment. We have, of course, those holes. That's going to become a point cloud in the next step. So here, now I'm going to take those elevated objects, and I want to do essentially the same thing. I want to just take my elevated objects. I'm also going to write in the color values for those right into the point cloud, and this time it's going to do the same name, but be elevated. And we'll run this. This layer also becomes available in our point cloud mixing. Now, if I add it on, I can see we've also colorized those elevated objects. So we're seeing the color now added to our houses and the trees. We still have some gaps though, and those gaps are coming from those conflict areas. So those areas that we identified as elevated in one data set, but not in the other. And what do we want to do with these? So that is this next step. If I just turn on my classification view here, I can see these objects, and I'm just going to apply a simple pixel-based object resizing algorithm here, just selecting this temp class 02 that contains my conflicts, and I'm going to grow it. I'm going to grow it by 4 pixels. And that 4 pixels is defined here through the number of cycles. I'm just going to simply apply this 4 times. And I'm only want to grow into unclassified image objects. This gives us will give us a little bit more material to deal with when we convert this into the point cloud. So subtle, but we did increase the size here. As you can see now, if I zoom in, that this overlaps with some more points out here, that simple growing. And finally, we're going to just apply another one of these create temporary point cloud algorithms. This time, I've set my temp class 2 from the class filter, and I want to influence only the ground class that has been identified that we've used in the automatic point cloud classification, and I want to just colorize those points within this point cloud. I'm going to write these out as color B conflict, and again, I'm going to be filling these red, green, and blue values. This is where we start to add the intelligence though. Instead of just simply adding as they overlap to a pixel, because this would again take those green pixels that were in the image and apply them to the street. Now I'm using relational features. So let's take one step back out of this algorithm, and we can take a look at those. Those are again customized features, so they're listed then under class related, customize. I set these up in the beginning, and I'll just open one of these up to edit it. And what are we looking at here for this relational feature 1? First of all, the relational function is set to neighbors, so I'm going to be looking at neighboring objects. And what layer am I interested in? Here I'm interested in mean layer 1, which corresponds to my red band. And I'm interested in these neighboring values in mean layer 1 for unclassified image objects. All right. So we're going to be looking to fill the RGB values of these yellow objects based on neighboring image objects and their layer value 1. That is why we created that chessboard segmentation to give us a more localized mean layer 1 as a neighboring image object for this. And the same concept is for relational feature 2 and 3, only that those reference image layers 2 and 3. So those are the values those feature values that we'll be using to colorize this point cloud. And now we're going to execute this. Turn off the classification. And I can come back in. I see this third layer is now available. And I see now this has been added. Now I have all 3 of these layers, all my points are essentially back together again. And you can see some slight differences here because we used a sort of a broader stroked chessboard segmentation, if you will, here. Remember, it was set to I think about 50. So you can optimize this by changing the segmentation parameters. So that's all very nice. The final step, though, is now to combine all 3 of my temporary point clouds into a new single point cloud layer. And again, this is the functions that we can use is create temporary point cloud algorithm for. In this case, the method is I'm just going to create a point cloud or a copy or subset quickly. And what am I doing is I've just defined the point clouds that I would like to put into this new temporary point cloud as my conflict and my non-elevated and my elevated point clouds. So if I just click on this, you'll see I've defined these point clouds to use. And we're going to call the output as PC color B. So we'll run this. And then once this is run through, I can actually remove those other point clouds. Those were essentially just a means to an end here. And I can just maintain my color B. So now I've deleted all those previous point clouds, those individual point clouds, and now I simply have this color B, which is a combination of all three. And if we come now and investigate this area using the 3D tool, we can see this better. Here's a great spot to look at, where we can see that these points on the ground are now given that the mean color derived from those blacktop objects, those road objects in the surrounding, and don't have the color of the car at this, or excuse me, not the car, the tree at this point. And if we compare this to our simple method of looking at point cloud colorization, I think we can see the differences and the advantages rather well. So I'm going to turn on the other point cloud in this split screen, and just make sure we sync these views. So we can see now, if I look at synchronize these views, that in this case, again, on the right-hand viewer, we're looking at that point cloud A. That was the basic example of purely taking overlapping pixel values and applying those to fill the point cloud fields, versus a more smarter method through the introduction of the image objects and how we can use various relational features, neighborhood functionality, the strengths of image object analysis to colorize these point clouds. We see here these points have a nice street color, whereas these points are reflecting the color of the tree due to the offset between the imagery and the LiDAR flight, or the point clouds that was created here. So again, we can zoom in here and look at this in our 3D viewer. Again, this is point cloud A, where we see the false color put down onto these points, that the color is coming from the vegetation of that overhanging tree. Whereas if we look at this, the results from the intelligent method, this advanced method, if you will, we will see that the point cloud has the color of the surrounding objects, in this case the street objects that are more correct, if you will. So we'll take a look in here, also within our 3D. And we can see here that this image of these points now are the grayish of the street, and not the vegetation from the imagery. So this is find a nice example. Of course, you can adjust the rule set to any individual situations that you may have in your imagery. Maybe a more finite segmentation, if you will, if you wanted to have more detail, or broader stroke if you didn't want as much detail to colorize this point cloud. But it also demonstrates the strengths of being able to combine the object-based tools that we have within eCognition and in the point cloud features and things that we also have introduced within 9.3.1. That being said, our power hour is up. I apologize for the audio problems we had earlier. I hope everybody was able to get back on track when we shifted. And if there are any questions, Sebastian, let's take some minutes here and look to any questions that might have popped up in the course of the presentation.
Mm-hmm. We have some questions in terms of performance. One question is there a process? Is the processing on GPU or CPU?
That's an excellent question. In this case, it was just using a CPU. We do have GPU support for things like the neural networks, working with CNN. But in this case, this was CPU processing on this machine.
Okay, perfect. Another question is if the logic or parameters of the point cloud classification is customizable. And
yes, absolutely. Go ahead. Was that the full question?
No, there was another question then regarding this. If the default parameters are documented in the manual as well.
The default parameters of what?
Of the point cloud classification, I assume.
Okay. Well, this in terms of this rule set is not in any type of a manual. We can make it available within the eCognition community if there's interest for that. But yeah, it's like any rule set, you can customize it as much as you like to tailor it to the needs of your particular data set. For example, you might find that the initial scale parameter doesn't fit your particular data needs, and you can adjust that and any elements of this. You can use other relational features. You can expand out to different neighboring objects that you want to consider. So yes, it's very customizable to different situations.
Perfect. One last question maybe. Is there any other export format than LAS or LAC?
No, it's LAS and LAZ are the industry standards. At the moment, we don't support anything other than those. If you wanted to convert from LAS to something else, it would have to be done outside of the eCognition software.
Perfect.
Anything else? 1, 2 more before we sign off for the afternoon?
Maybe let's wait a few seconds.
If there are no more questions coming in here live, then I'd like to thank everybody that attended this live session for your time. Any of you that pick up on the recording later, I hope you enjoy it. If you do have any questions, you can always send these to us. If you have specific questions of what maybe you missed something within the webinar or something wasn't clear enough, maybe some very detailed questions to a parameter that we used here, please feel free to contact us, and the best place to write is support@ecognition.com. This will assure that your question gets answered as quickly as possible. And Sebastian, one last chance. Any question coming in last minute?
No, I think we can close here.
No, it sounds like we're done. In that case, again, thank you for attending. I hope you found this Power Hour helpful on how these not only these new algorithms creating temporary point clouds can be configured, but also how we can colorize and work between image objects and point clouds within eCognition. So see you next month at our next webinar, and again, hit us up with any questions you have in the meantime. Have a good rest of your day.